Okay, so we have this question here. You sent it says you want to be able to withdraw 25,000 from your account each year for 20 years after you retire. You expect to retire in 15 years. If your account earns 6% interest, how much do you need to deposit each year until retirement to achieve your retirement goals? So this is going to be a two-part problem. The first thing you want to figure out is how much money do we need at retirement? So how much money do we need at retirement? So that I can have this. I want this scenario. I want to be able to withdraw 25,000 every year for 20 years. So I'm going to pull out all the variables I know. My withdrawal amount is going to be 25,000, so that's D. Each year I'm taking money out. So K is going to be 1. That's the number of compounding periods. N is 20, and my interest rate is 6%. So since I'm taking $25,000 out each year, that's going to be a payout annuity. So I'm going to copy that formula from my formula sheet. So I have P sub n equals, now it's going to be D, so I'm going to write 25,000 times, let's forget that formula, 1 minus 1 plus our interest rate, 0.06, divided by K, which is 1, to the negative 20 times 1, all over 0.06 divided by 1. Just double check to make sure I didn't make any mistakes there. Yep, we're good to go. So this is going to tell me how much I need in the account at retirement so that I can have this goal. So I'm going to start with this innermost fraction here. I'm going to do 0.06 divided by 1. Obviously, I'll just give you 0.06. Then I'm going to add 1 to that. I'm still in these small parentheses, plus 1. Now that's this whole thing here. So now I'm going to take that and raise it to the power of negative 20. So I'm going to do caret negative 20. So that's everything except for the 1 minus. So I'm going to do 1 minus my answer. 1 minus, I can grab that. So then that's this whole parenthesis right here. So now it's just a matter of multiplying by 25,000 and dividing by 0.06. Multiply by 25,000, divide by 0.06. So if I want to be able to withdraw $25,000 every year, I need in my account at retirement $286,748.03. 286. 748. 03. That's what I need on the day I retire so that I can have the situation I want. So that's the first part. The second part says, well, how much should I deposit each year until then to get my goal, to get this? This is what I want. How much should I deposit each year for 15 years to get that? So now my K is going to be still 1 because I'm depositing each year. My N now, though, is going to be 15. And everything else stays the same. So I want to deposit multiple times. So that's going to be an annuity formula. So I'll copy that from the sheet. I'm just going to write out the values while I write it out. So I want this at the end of it. So this is my P sub n. 286, 748.03. I'm looking for how much do I deposit? 1 plus 0.06 over 1 to the 15 times 1 minus 1. I'm just copying the formula. All over 0.06 over 1. Now it's just a matter of put that on my calculator again. I'm going to do 0.06 divided by 1 gives me 0.06. Next thing I do is add the 1. Now I'm going to raise it to the power of 15. Okay, then I'll do that minus 1, so minus 1. And then divide by 0.06. So I get 286,748.03 equals D times this. So then I'm going to take that number, 286,748.03, divided by the coefficient of D. So I get $12,319.49. That's how much I have to deposit every year for the next 15 years to get my retirement goals.